Hi everyone, Architecture and Operating Systems. We are in week 6 and today I'm going to talk about the Boolean algebra, its laws and rules. But first of all, what is Boolean algebra? Boolean algebra is the branch of algebra in which the values of the variables are the true or false, or let's say 1 and 0. And instead of elementary algebra, the main operators and operations are and, or, and not. If you remember in the week 3, when we discussed the gates, we talked about AND gate that we show it by a dot or without any sign, OR gate by addition. Also for AND, we could use this one. For OR, we use that, and NOT gate. So these are the main operations for Boolean algebra. But why Boolean algebra is used? Because so far what we've done, we've tried to combine different gates and do some operations with those logical gates, such as adder and subtractor. But the question is that is there any way that we reduce the number of the gates that we use for our circuits? Is there any other way that we can improve the efficiency of our circuits by reducing the number of gates? All of them can be answered and addressed by Boolean algebra. And Boolean algebra is a very clever way that we can simplify the circuits. So here, I'm going to introduce Boolean algebra, the laws and the rules, and show you how we can simplify the circuits. So let's start. First of all, AND gate. AND gate is this one, like A and B. And as I said, I can show it by A and B, A and B. OR gate. A or B, A or B. And NOT gate is this one, that I can show by A not, for example, if this is A. So we've already learned them in the week 3, 4, and 5. Now, what are the rules? We've got a number of the rules that I go one by one and explain you how it works. First of all, we've got commutative rule. What is commutative? In commutative rule, we say that A or B is exactly the same as B or A. It means that there is no difference. If you say A or B, it's equal with if you change the inputs order, like that. The same for AND gate. A and B is the same as B and A. Sometimes to actually use this rule, it's better to change the position of these inputs. So just draw it very quick. A and B is exactly the same as B and A. They are the same. Next rule is associative rule. Associative. What is associative rule? In associative rule, we say that if we have X equal A or B or C, you can change, if you have all of them are OR gates. We have 2 OR gates here. This is one OR gate. This is actually this is one OR gate and this is the other OR gate. What we can do, we can change the parentheses or we can change the position of the OR gate. I mean that here, if I want to draw that, I have A or this is A or B or C. This is OR gate. So if I have this, it's exactly the same that if I change the order. I say A or B or C. So it means that I can change the place of the OR gates if I have only OR gates there. You can change the parentheses simply. So in that case, I would have A or B or C. They definitely give you the same answer, but you can change the position and place of OR gate. Same story for AND gate. If I have A and BC is the same as change the parentheses, A and B and C. There is no parentheses here. It means that if I have A and, this is AND gate, BC, this is A and B and C, this is the same as A and B, the output of that in another AND operator with C. So again, you can change the parentheses of these inputs. These are very simple rules, and I think it's quite easy to understand how they work. The next rule is distributive rule. This is an important rule. What it says, if I have x equal A and B or C, let me draw that for you. I have B or C. Then AND gate. This is A and B or C. What I can do, I can use the fact, if you remember from the actually previous years of your studies, you can multiply them, let's say, or you can remove the brackets by using the AND operator here and write it as A and B, because this is A and B or C. We can say A and B or A and C. That's a very important rule. And it works in opposite direction as well, I'll tell you. So it means that this is equal with A and B, you have AND gate between them, or A and C, another AND gate. I've got to have one input of A and C. So they are the same. Which one is more efficient? Definitely this one. Why? Because here we have 2 gates, here we've got 3 gates. But what is important, that this can work in both directions. It means that if you have such Boolean algebra, you can write it as A and B or C. So what is a technique that we can use? Similar to what we have in the normal algebra, we can factorize it. We can factorize A. If you factorize A, what you get is that A, because you've got the common factor of A in both of them, A, open the bracket, because it's an AND between them, and stays here. From the first term, B remains. From the second term, C remains. And because the addition or OR gate is between them, so we use this thing. Right. So in that case, A or A and B or C can be written as AB or AC. Don't forget that whenever we have a common inputs, we can use distributive rule. This is a very important rule that you need to know. Some other rules, I call them rule number 1, 2, 3, and at the end I will give you a cheat sheet or formula sheet that you can actually use that. Rule 1. What is rule 1? Very easy. Rule 1 says that A or 0 is equal with. If we have OR gate, one input is A, one input is 0. What do we do? Look guys, it's quite important. A or 0, it's an OR gate. When one of the input is 1, we get 1. So if A is 0, we get 0. If A is 1, we get 1. So it's totally depend on what A is. So A or 0 is equal with A. Rule 2. Now, A or 1. Again, I've got OR gate, and the constant is 1. So this is OR gate. When at least one of the inputs is 1, the output is 1. So we already have 1. It doesn't matter if A is 0, because one input is 1, the output is 1. So A or 1, B or 1, C or 1, whatever is always 1, because we've got one high input. Rule 3. Let's talk about OR AND gate now. A and 0. I've got AND gate, A and 0. So this is an AND gate. AND gate, the output of AND gate is 1 when both of them are high or 1. Because we've got a constant of 0 here, doesn't matter what A is. Because we've got one input at 0, the output is always 0. So A and 0, B and 0, C and 0, anything and 0 is 0. Rule 4. Rule 4 is A and 1. Again, I've got AND gate, A, 1. So, if A is 0, A, 0 and 1 is 0. If A is 1, 1 and 1 is 1. So, it totally depends on A. So, in that case, A and 1, or 1 times A is A. It depends on what A is. Rule 4, A and 1, B and 1, C and 1 is 0. Very basic and simple rules. The combination of constants 0 or 1 with an input using different gates, A and or. Rule number 5. Rule 5. Very easy. A or A, and rule 6. Let me tell you these two together. A or A and A, it depends on A is. If A is 0, 0 or 0 is 0. If A is 1, is 1. So it means that if you have OR gate and you've got OR gate with A, it depends on what A is. If A is 0, you get 0. If A is 1, you get 1. The same story for AND. If you have AND, it depends on what AND is. A is. If A is 0, you get 0. If A is 1, 1 and 1 is 1. So in that case, guys, if you have a repeated input, you can reduce it to 1. If you have two A and A or A, you can say this is A. So we are getting to more important rules. Rule number 7. A or A not. It's important. So I've got OR gate. In one, I've got not, like that. So look, guys, if A is 1, for example, here is 1, here will be 0. 1 or 0 will be 1. If A is 0, here will be 0, here, if you invert it in this, using the NOT gate, you get 1. So 0 and 1 is 1. As you see here, the output of this is always 1. So A or not A is always 1. It's important because that's a structure. If you have an input, whatever it is, or with the inversion of that, with the inverted version of this, you always get 1. That can be A, that can be B, that can be C, whatever. So any input in an OR gate with the inverted version of itself will be 1. Rule 8. Now let's talk about AND gate. A and not A. So we've got an AND gate. One input is A. We've got to invert the other one. So same story. If we've got 0, here I have 0, here I've got to invert it. What we get is 0. AND gate. When one of them is 0, you get 0. If this is 1, 1, here will be 0. Again, it will be 0. So what is important? When you have an AND gate and you have A and not A, it's always 0. Why? Because if A is 1, the invert of A is 0, or if it is 1, you get 0, 0, 1. Always you have 1, 0, and because of that, the output is always 0. Again, this is a structure that we get always. Actually, these are two inputs, and the output is always 0. Rule 9. Very easy. A not, not. If you want to invert that, what happens? Not, not. It means that you've got to invert it twice. So what do you get? Not, not. Same thing. If you invert it twice, 0, because here, imagine that's 0. 0, you get 1, 1, you get 0. 1, you get 0, 0, you get 1. So whatever A is, you get it at the end. So when you invert it twice, actually, you haven't made any changes to that. So this is rule 9. What is important is rule 10. Rule 10 is very important. I put this asterisk here because to show you that it's very important. A plus AB. Let me draw that for you. A or A and B. So, what do I get? A or A and B. In this one, actually I can delete this and do it like that. So, how to solve this? Look guys, I told you in the distributive rule here, I said that when you have a common factor, you can use distributive rule, and I said that it's very important. A and B or A and C, because I've got the common input of A, I can use distributive rule and make it more efficient. Because here I have 3 gates, I've got 2 gates here. So I can take a common factor of A here in the distributive rule. So I use this distributive rule, distributive rule. And I see A in both terms. So I take a common factor of A. If you take a common factor, A and guys, can I write A as A and A? Sorry, A and 1. Because A and 1 is always what? A and 1, where is that? A and 1, rule number 4. A and 1 is always A. So you won't change that. So I can use rule number 4 here and say this is rule number 4. This is rule 4. I can write this as A and 1 instead of A. Now, if you take a common factor of that, if you remove A from here, what remains? Is 1. If you now remove or take away A from A and B, what remains? Is B. What I have between them? It's O. This is distributive rule. A and 1 or B. 1 or B. What rule is it? Rule number 2. A or 1, because it's an OR gate. One of the input is 1, the output is always 1. So this is rule number 2. This is rule 2. A and 1 or B, I can write it as 1. I get A and 1. What is A and 1? I've got this rule as well. As it's a combination of, oops, it's a combination of rules here. A and 1 is A, because it depends on A. That's an AND gate. It totally depends on, what rule was it? That was rule number 4. Again, yes, that was here, rule 4. I use rule 4 again. Rule 4, and it's equal with A. So at the end of the day, what's important? A or A and B is equal with A. It means that it's equivalent with A, whatever A is. So this structure is very important. So whenever you see that, you can actually take a common factor and follow the rules. At the end of the day, if I say that input 1 is triangle, input 2 is circle, if I have triangle or triangle and circle, you've got to follow that, and you will see it's the same as the triangle. So A or A and B is the same as A. Very important rule. This is very important rule. Another rule which is very important, and the last rule for this part is, sorry, we have 2 more rules. Rule 11. Rule 11. I think this is the most important rule that we have. Very important. What is that? It's A or A not B. What's that equal with? Let me draw that first. This is A, OR gate. You've got to invert that. Oh, it's not a good AND gate for sure. Let me draw it in this way. We've got one input from that, and we've got B. We want to see what's that equal with. So I want to simply, using the rules that I told you, and also I've got this one here that I can actually use it here, which helps me to go back to the roots. There you go. I can actually take it a bit higher, and yep, it's available on the Moodle, and you can use this formula sheet. So what to do? A or A not B? In the previous one I had A or AB, which I said it's equal with A. But now A or A not B. So what I've got to do? A. In the previous rule, I told you that A, this is rule number 10. A is what? A is equal with A or AB. So instead of A, I write A or AB plus A not B. What I did, I substitute A with A or B. I got it from the previous rule. Now I have these two. I have these two. In both of them, B is the common factor, distributive rule. I said that whenever you have distributed rule, so what you can do, take a common factor. Do that. What is the common factor here? Is B. Take a common factor, open the bracket. What remains from the first one is A. What remains from the second one is not A. A comes down. A or not A, what rule is it? Look, if it is 1, this is 0. If it is 0, this is 1. It's an OR gate. This is always 1. But I told you in rule 7, what we get is 1. So it's equal A or B and 1. B and 1 definitely depends on what B is, because an AND gate. Here, rule 4. 1 and B is B, A or B. Excellent. So A or A not B is equal with A or B. This is very important. And look, instead of that circuit, instead of this circuit, what I can do, I can say this is equivalent with A or B. There you go. But more important than this is the structure. This one, rule 11, says that A plus A not B is equal A or B. If I look at that as a input, if I have, for example, A as this and circle as B, in this structure I have triangle or triangle not circle is equal with triangle or circle. It means that if I have A and A or B, I get A or A not B equal A or B. But let's say that triangle is A not. What I get? A not or A not B equal A not or B. A not is A, so it's equivalent with A not B, A not or AB is equal with A not or B. We use that a lot. So guys, it means that this is a structure. We need to know this structure, and I proved that how it works. The last rule that we have is rule 12, which is A or B, A or C. I would say this is similar to distributive rule. And what we've got to do, we've got to remove the brackets, similar to what we did in the basic algebra. You should, the same as distributive, you should multiply them. A or A or A and A, sorry, because that's an and between them. A and A or A and C plus B and A. This is rule 12. Plus B and C. So A plus A, C, I can write it as rule. What is that rule? Let me copy that for you again, that we use the rules. So look, AB, commutative rule, AB is equal with BA. So I can write it as AB plus BC. Guys, what is this rule? This is rule number 10. That is very important. Again, you can take a common factor or follow the rule 10. A plus AC is A. What is this rule? Again, rule 10. Yeah. A or AB is A. So at the end, A or B and A or C is equal with A or B, C. So these are the rules that we have. All of them are here. We've got two more Demograph rules that I will teach you next week, and we solve more problems. But how we use them? First of all, you need to be really good in these rules, and you need to know how they work. But let me solve a very simple example and show you how it works. For example, I have this circle. I want to simplify that using the rules that we have. Again, rules are here. So first of all, you've got to write what x is. So x is equal with what? I've got an OR gate. Okay, OR gate. You see, we've got OR gate with two inputs. One of them is B. The other one, again, it's another OR gate. One input is A. The other one is A and B. This is my circuit. I translated. So actually, I don't need this bracket, but just wanted to show you. This is an OR gate, big one. One leg is B, one leg is A or A. How to simplify that? Follow the rules. What is this rule 10? I said very important. A or AB is A or B. So it means that this is equivalent with A or B. As you see, guys, and I said at the beginning, that we use Boolean algebra, that we can simplify our circuit and use less number of gates. And definitely, just think about the process time. The process time for this is longer than that because it's only one gate, but we have 3 gates. Please watch this video carefully a couple of times and learn all the rules that we discuss here and do all the exercises this week. From next week, for the next 2 weeks, we solve more problems about simplification using Boolean algebra. Thank you very much.